All right, welcome to today. Today we're going to do some solving systems of linear equations that involve fractions. So either the answers are going to be fractions or the original equations are going to be fractions. This is really just to help us do a couple problems that involve fractions so that we get a little bit more comfortable with it. So here's our first two equations. Negative 2x plus 2y equals negative 4 and x plus y equals 1. So when I see this, I'm going to right away, I'm going to decide that I'm going to do the second equation. I'm going to do a substitution method with the second equation. I'm going to subtract y on both sides of the equal sign to turn that second equation into x equals negative y plus 1. I'm going to substitute that back into the first equation. So negative 2x plus 2y is negative 4. And we know that x is negative y plus 1, so negative 2 times negative y plus 1 plus 2y equals negative 4. So at this point now I'm going to distribute the negative 2 into the brackets. So negative 2 times negative y is 2y. Negative 2 times 1 is negative 2. And I have plus 2y equals negative 4. I'm going to group my like terms at this point. So 2y plus 2y is 4y. So I have 4y subtract 2 equals negative 4. Then I'm going to add 2 to both sides of the equal sign. So I'm trying to isolate my y here. So I have 4y equals negative 2. And then I divide everything by 4. And I get y equals negative 2/4, which reduces to negative 1/2. So y equals negative 1/2. I'm going to substitute that back in. I'm going to use the second equation here. So x plus negative 1/2 is 1. So x plus y equals 1. I'm going to add 1/2 to both sides. And I get x equals 3/2. So 1 plus 1/2 is 3/2. So my solution at the moment is 3/2 and negative 1/2. What I want to do is I want to verify that answer. So I want to take my solution of 3/2 and 1/2 and plug them back into the original equations. So verification. So I have negative 2x, so negative 2 times 3/2. Plus 2y, and y is negative 1/2, and that's going to equal negative 4. Negative 2 times 3/2 is negative 3. 2 times negative 1/2 is going to be negative 1. And negative 3 plus negative 1 is negative 4. And negative 4 does equal negative 4, so the solution of 3/2 and negative 1/2 does solve the first equation. The second equation is x plus y equals 1, so x being 3/2 plus y, which is negative 1/2, and the equation says x plus y equals 1. So 3/2 plus negative 1/2 equals 1/2. 3 subtract 1 is 2. And 2 over 2 is 1 when I reduce it, so that is verified as well. So the solution for this first equation is 3/2 and negative 1/2. Second example. You can see right away that my first equation is negative 2x plus 4y equals negative 20. My second equation is x plus 4y equals 8. See right away that there's a common coefficient between the first equation and the second equation. So I'm going to subtract these two equations from each other because they both have a 4y. 2x subtract x is negative 3x. 4y subtract 4y is 0. Negative 20 subtract 8 is negative 28. And then I'm going to divide by negative 3 to get the x by itself, and I get x equals 28 thirds. So that's not a nice fraction that I'm going to have to deal with now. 28 thirds is a bit of a Bit of a different fraction. I don't want it as a decimal because of the repeating decimal, so I'm going to keep it as a fraction. I'm going to take that, I'm going to plug it into the second equation because it's a single x, the coefficient is 1x. So then I have x plus 4y equals 8, and the x is 28 thirds. So I have 28 thirds plus 4y equals 8. I'm going to subtract 28 thirds on both sides right here. So right here, I'm going to just shift and do my scratch work up here. I have 8 subtract 28 thirds. So that becomes, so I need a common denominator. So this is 8 over 1, so it becomes 24 over 3. Subtract 28 over 3, which is negative 4 thirds. So 8 subtract 28 over 3 becomes negative 4 thirds. I was saying to my class that for the test, so it might be a good idea to have a piece of scrap paper on the side where you can do some of these adding and subtracting, multiplying, dividing of fractions, just so that I can save some space for myself, so that when I do 8 subtract 28 thirds, I can do this step on a scrap piece of paper and quickly get the answer of negative 4 thirds and save space for myself. So now that I'm here, I'm going to divide by 4. So again, I want to make sure that I do this right, so I'm actually going to write it out. So I have negative 4 thirds being divided by 4, which is the same as dividing by 4 over 1. As we know from grade 8, what that means is this is the same as negative 4 thirds times 1 over 4. So negative 4 times 1 is negative 4, and 3 times 4 is 12, and that reduces to negative 1/3. So y is negative 1/3. So again, scrap piece of paper to do that, the negative 4 thirds divided by 4, where I have some scrap piece of paper, a little bit of extra space in order to actually write it out and do it properly. Okay, so now I have y is negative 1/3 and x is 28 thirds, so my solution is 28 thirds and negative 1/3. I'm going to take those two, my solution, and put them into both equations so I can verify and make sure that I am correct. So I have negative 2 times x, so negative 2 times 28 thirds plus 4 times negative 1/3 equals negative 20. This becomes negative 56 thirds. Subtract 4 thirds is negative 20. Negative 56 subtract 4 is negative 60. And negative 60 divided by 3 is negative 20. And negative 20 does equal negative 20. So the solution of 28 thirds and negative 1/3 solves the first equation. My second equation, which is x plus 4y equals 8. So I have 28 thirds plus 4 times negative 1/3 is going to equal 8. So I have 28 thirds. 4 times negative 1/3 is negative 4 thirds. 28 subtract 4 is 24. So I have 24 divided by 3, which is 8, and 8 does equal 8. So my solution of 28 thirds and negative 1/3 solves both equations. So again, just a suggestion when I'm starting to deal with some of these fractions is that I have a piece of scrap paper where I can do the math quickly and efficiently. I think most of the people that are running into issues when they're doing these questions is they try to do this in their head, or they try to do this in their head, where you can just write it out, and then once it's written out, you're like, oh, that's how I do it, and you can get the right answer that way. When we flip to the back and get example 3 and 4, now we're dealing with fractions right in the question. So my first equation is 1/3 x plus 2/7 y equals 14/3. And my second equation is 1/7 x subtract 1/7 y equals 1/7. So you can do these a bunch of different ways. You can keep them as fractions. You can convert them to decimals, although with the repeating decimal I wouldn't do that with this particular question. Probably the easiest thing to do is take each equation and multiply it by the LCM of the denominators. So I have 3 as a denominator, 7 as a denominator, and 3. So the LCM of those 3 numbers is 21. So I'm going to multiply each term by 21. 1/3 x times 21 becomes 21 over 3, which is 7x. 2/7 y times 21 becomes 42 over 7, which is the same as 6y. And 14 times 21, I don't even have it written down here. What is it? 14 times 21 is 294, and then I divide that by 3 and I get 98. And then on this bottom, the second fraction, or second equation here, all my denominators are 7, so I'm going to multiply them all by 7, since the lowest common multiple of 7 is 7. So the second equation becomes 1x subtract 1y equals 1. 7 times 1/7 equals 1. 7 times 1/7 equals 1, and 7 times 1/7 equals 1. So now I have 7x equals 6y. 7x plus 6y equals 98. At this point, I'm going to take the second equation and I'm going to do substitution again. So I'm going to add y to both sides, and that second equation becomes x equals y plus 1. I'm going to substitute that into the 7x plus 6y equals 98. So 7 times x, which is y plus 1, plus 6y is 98. So now I'm going to distribute the 7 into the brackets, and I get 7y plus 7 plus 6y equals 98. At this point, I like to group my like terms together. So 7y and 6y is 13y. So 13y plus 7 is 98. Then I'm going to subtract 7 both sides, and I get 13y equals 91. And 91 divided by 13, so I'm going to divide everything by 13, and I get y equals 7. So I'm going to take my y equals 7, I'm going to put it into my second equation here. X take away y equals 1. So x take away y, which is 7, equals 1. So I'm going to add 7 both sides of the equal sign here, and I get x equals 8. So I have a solution of 8, 7. Now, something that I've said in my class several times during this unit is when I verify, I don't want to use the 7x plus 6y equals 98 or the x take away y equals 1 equation. If I made an error when I went from the original equation to those, that error is going to remain consistent in my verification. I want to use the original equations when I'm verifying. Okay, so I'm going to have to use those original equations so that I can actually verify my work. So the original equation is 1/3 x, which is 8, plus 2/7 y, which is 7, equals 14/3. 1/3 times 8 is 8/3. 2/7 times 7 is 2. I want common denominators, so the 2 becomes I multiply each top and bottom by 3, so it becomes 6/3. And 8 plus 6 is 14. So 14/3 does equal 14/3. So I've verified with the first equation. Again, I want to use the original equations that are given, just so that if I made an error in the first step, I can catch it. My second equation now is 1/7 x, and x is 8. Subtract 1/7 y when y is 7 equals 1/7. 1/7 times 8 is 8/7, and 1/7 times 7 is 7/7. So I have 8/7, subtract 7/7, and that is 1/7 equals 1/7. So my solution of 8/7 works for both of the original equations. Last example for this section. I have 1/4 y subtract x equals 3/2, and 1/4 y plus 1/6 x equal 1/3. So again, I want to look for the LCM. So my denominators here are 4, 1, and 2, and the LCM for those is 4. So when I multiply that top equation by 4, it becomes, so 4 times 1/4 becomes 1, so I have 1y, subtract 4x, 3/2 times 4 is 12/2, which is 6. And then that second equation, I'm going to multiply it, so I have 4, 6, and 3, and the LCM there is 12. 1/4 times 12 is 12/4, which is 3y. 1/6 x times 12, so 12/6 becomes 2x. And 1/3 times 12 becomes 12/3, which is 4. So now I have two equations like this. I'm going to do this one using the elimination method. I'm going to multiply that second equation again by 2. So my two equations are going to be y take away 4x equals 6. And then this second equation becomes 6y plus 4x equals 8. I'm going to multiply it by 2. So now I can use the substitution method. I can add, because my coefficients are opposites, negative 4x and positive 4x. So y plus 6y is 7y. Negative 4x plus 4x is eliminated. 0x, it's gone. And 6 plus 8 is 14. Now I solve for y. So 7, I'm going to divide by 7 to get rid of that 7 and isolate my y. I get y equals 2. Take y equals 2 and I'm going to plug it into one of these equations up here. I'm going to pick that first one. Y take away 4x is 6. So y, which is 2, subtract 4x equals 6. So I'm going to subtract 2 on both sides. I get negative 4x equals 4. And then I divide everything by negative 4 and I get x equals negative 1. So my solution is negative 1 and 2. And just like I did in the previous equation, I want to make sure I'm using these original equations when I verify. I don't want to use these equations that I've created. I want to use the original equations. So when I verify, I'm going to use 1/4 y. So 1/4 times 2, subtract x, which is negative 1, is going to equal 3/2. 1/4 times 2 is the same as 2/4. Plus 1 is 3/2. This is the same as 1/2. This is the same as 2/2. And I have 1/2 plus 2/2, which is 3/2. So my solution of negative 1 and 2 verifies the second equation, or the first equation. And now the second equation, I want to use the original one, is 1/4 y. So 1/4 times 2 plus 1/6 x, which is 1/6 times negative 1, is going to equal 1/3. 1/4 times 2 is the same as 2/4. 1/6 times negative 1 is negative 1/6. Okay, so now I want to use a common denominator. So common denominator here is going to be 12. This is going to end up being 6/12. Subtract 2/12 equals 1/3. 6 take away 2 is 4/12. And when I reduce 4/12, I get 1/3. And 1/3 does equal 1/3. So my solution of negative 1, 2 solves this equation. So again, what you want to do here when the equations start with fractions as coefficients, I want to multiply the